Hello everyone, welcome to the part 6 and the last part of our discussion on transaction and schedule. In previous parts you have seen that how can we make a schedule consistent by making it either serial schedule or by making it a serializable schedule. Now consistency is not everything for schedule. A schedule should be recoverable. What do you mean by recoverability? Now, in case of failure, we know that a transaction have to be rolled back to ensure atomicity. Now, when a transaction is rolled back, then it will obviously affect the schedule. Now, as it is affecting the schedule, the question is that if in case of failure in any of the transactions, can I make the database consistent with its previous stage? If the database is consistent in case of failure, then we can say that the schedule is recoverable, otherwise it is not. But before going into the recoverability and other properties of the schedule, we are going to discuss the operations of a transaction. Means we have learned that the main operations are read and write, a combination of this. Now, how a SQL statement looks like in case of read, in case of read write, and in case of write, that we are going to discuss first. So, in case of read operation, so simply a select query is basically we are reading the data from the database. So, it is a read operation, only read operation. Like here we have mentioned select salary from the employee, so we are reading the salaries from the employee. In the next one, we are specifying that from that employee whose employee number is E7369, that person's salary will be read. Now this kind of thing is only the read operation. Now when we talk about the read write operation, then the update queries are basically the read write operation. Why? Because look at this update query. Update employee set salary equals to salary plus 2000. Here what we have to do? We have to read the previous salary, then we are adding 2000 to it. But the employee number is this. So here first we need to read that salary, then plus 2000. So we are reading, then updating, then this equals to will write, or this total query will write the data to the database. Similarly here we are performing the reading of the salary, then we are giving a 15% increment, then the total query will write the data into the database. So these are the examples of read write of examples of queries where the read write operation of the transaction is performed. Now in case of blind write, we know that it plays an important role in case of blue serializability. In case of blind write, a simple insert query can be an example of a blind write operation, because we are not reading anything, we are just putting that value into the database. Similarly, update, this kind of update where we are not using the previous salary, we are just inserting a new value into the salary field of an employee. This is also a blind write operation. So you may have the now you have the idea how a SQL query will look like in case of a transaction. Now next we are going to discuss about the recoverability of a schedule. Now consider the schedule 1. What it is doing, there are three transactions T1, T2 and T3. T1 is reading the data item A, which is then it is writing that one. Then T2 is reading the data item A, which is written by the T1. Then it is writing and performing the commit. So after this commit, that all the changes made by the T2 will be saved in the database, will be permanent in the database. Now T3, what it is doing, it is reading a data item written by T2. Now as it is committed, it is, you can see that it is not a dirty read, right? Next, it is writing the data item. Then the T1 is completing or terminated by using the commit statement. Then the T3 is committed. What will happen over here? Suppose the T1 fails at this position before committing the transaction. So what we need to do? We need to roll back all the operations of T1. Now, rolling back all the operations of T1 means we have to discard the effect of this write operation of T1, but T2 have already read that data and performed some job and written that data into the database and now already computed. So we cannot by we by rollbacking the T1 we cannot get the consistent database. So this kind of problem. So schedule 1 is suffers from non-recoverability problem. T1 is the schedule 1 is not recoverable because T2 is reading a data which is written by T1 and T2 have committed before the T1 have finalized or the T1 have terminated its job. Now consider the schedule 2. What we are doing, the operations are same but we have changed the order of the commit operation. So T1 is reading the data item A, writing that one, then T2 is reading the data item of A and and writing it, then T3 is reading the data item A and writing it. Now look at the order of the commit. The commit of T1 is done first, then the commit of T2 will be done second, and the commit of T3 is done at the end. So let us consider the failure. If T3 fails here, we can simply roll back the operations of T3 because no other schedule is dependent on that one. Now if T2 fails at this position before commit, then what will happen? Then we need to roll back the T3 as well as T2, but we can recover the database consistency of the data. We can ensure by recovering the database. Now if T3 fails, what will happen? We need to roll back T3, we need to roll back T2, then we need to roll back T1. But we can recover the database in the consistent state. So in this kind of schedule, in this schedule 2, we can see that it is a recoverable schedule. So if we go for the formal definition of a recoverable schedule, then we can say that in a schedule, if TI here the T1 and T2, both of them, writes a data item A, so T1 writes a data item A over here and T2 writes a data item A over here, which is read by Tj. Here T2 is reading the data item written by T1 and T3 is reading the data item written by T2. So T2 and T3 are the Tjs. Then Ti should perform the commit operation before Tj. So you can see that T1 is performing commit operation before T2, T2 is performing commit operation before T3. So by definition, we can say that this schedule 2 is a recoverable schedule. With this problem, with this example, the schedule 2, there is a problem. The problem is that though it is recoverable, you can see that failure of T1 making us roll back all the transactions. Now this kind of problem is called cascading rollback. Cascading rollback means failure of any transaction will have a cascading effect on all the transactions, on a number of transactions, and they need to be rolled back too. So schedule 2 suffers from cascading rollback. So Let us see what is a cascading rollback. It's almost similar to the schedule 2. What we are doing here, we are reading the data item A by transaction 1, then transaction 1 is writing the data item A. For simplicity, we are considering only the serial schedules because serial schedule will be consistent, so we need not to worry about the consistency at least. Now T2 is reading the data item written by T1, and T2 is writing the data item A. Then T3 is reading the data item written by T2. Now if there is a failure in this position, what will happen is that we need to roll back all the operations of T1. So this write operation will be cancelled, this read operation will be cancelled. But as T2 is reading the data item of the T1, then cancelling this will affect cancelling of this transaction also, T2 also. And as T2 is cancelled and the T3 is reading the data item of T2 written by T2, then T3 also need to be cancelled. So failure of T1 leads to cascading rollback of T2 and T3. So this schedule 3 suffers from the cascading rollback. Now the next kind of schedule, more better schedule, will be a cascadeless schedule. So what is a cascadeless schedule? When there is no cascading rollback, then we can say that the schedule is a cascadeless schedule. We can ensure a cascadeless schedule by not performing any dirty read. What does this mean? This means no transaction will read the data which is written by another transaction which is not committed. If you remember, the dirty read says that if a transaction reads the data written by other transaction and that the previous transaction hasn't committed yet, then it is a dirty read problem. So we need to remove the dirty read problem. Here we are having a dirty read problem. Here we are having a dirty read problem. So what is the way of now? Commit at when the transaction is over. So T1 is committed. So here it will move the database into a permanent state. Then T2 will read the data item, but already it is committed, so it is not a dirty read. Then T2 will write the data item and it will commit. So when the T3 is performing the read operation, it is not a dirty read because the T2 have already committed. So if T1 fails before commit, you know that we can fail at the active state or the partially committed state. Means we can fail at this position, or before commit. Suppose we are failing at this position, what will happen? We need to roll back only T1. It will not affect T2 and T3, right? Now, if T2 fails before commit, then what will happen? We need to roll back only T2. It will not affect T1 or T3. So by this we can remove the cascading rollback and create a cascadeless schedule by ensuring there is no dirty read problem. If we go by a formal definition of a cascadeless schedule, in a cascadeless schedule, if Tj wants to read the data item A written by Ti, here the T2 is reading the data item A written by T1 and T3 is reading the data item A written by T2, will not be allowed till Ti commit. So as the Ti committed, then I am going to as the T2 is committed, then I am going to allow this operation. If T1 is committed, then I am going to allow this operation to make the schedule a cascadeless schedule. Now consider schedule 5. Is that a cascadeless schedule? Yes, it is a cascadeless schedule because it tells about Now see what is happening. T1 is reading a data item, then it is writing that data item. T2 is writing that data item before T1 commits, and T3 is writing that data item before T1 or T2 uh, before T1 or T2 commits. Then we are committing T1, then we are committing T2, then we are committing T3. What will happen here? If T1 fails at this position, as T2 is not dependent on T1 because it is simply writing it, means it is performing a blind write. As it is performing a blind write, it is not dependent on T1. So I can simply roll back T1 without affecting T2 as well as T3. Similarly, if T2 fails at this position, we can simply roll back T2 without affecting T3 or T1. So there is no cascade. So here we need to concentrate on the term read. Now in the next kind of schedule, the next kind of schedule is much more stricter than this. This will not allow me to either read or write a data item written by another transaction which is not committed yet. That kind of schedule is called a strict. In case of strict schedule, TJ will not be allowed to perform any operation, means either it can be a read or a write operation on a data item A, which is already written by a transaction Ti till Ti commits. So here this operation will not be allowed, as well as this operation will not be allowed because the previous transaction which write the data item is not committed. So schedule 7 is a strict schedule. Now, so schedule 7 is a strict schedule, schedule 5 is a cascade schedule. Then a schedule is recoverable, then some of the recoverable schedules will be cascadeless, then some of the cascadeless schedule will be strict. In other words, we can say that all the strict schedules are cascadeless, but the vice versa is not true. Similarly, the cascadeless schedules, all the cascadeless schedules are recoverable, but the vice versa is not true. Now, what kind of schedule we are going to allow into our system? If we are going to answer that one, then you have to make sure that there are two conditions, there are two criteria you need to ensure. First one is the consistency, and the second one is the recoverability of the schedule. We are going to allow a schedule when the schedule is at least serializable, at least conflict serializable, and at least recoverable schedule. So if we put it into the diagram, we are going to allow the schedules which are conflict serializable and recoverable. Remember, it is and not or. So this is the minimum criteria to allow a schedule in the system: conflict serializable and recoverable. That's it from the part of transactions and schedule. Now, in this part, we have theoretically discussed the properties of a transaction and the schedules, what kind of schedules we are going to ensure my consistency, what kind of schedules are going to ensure my recoverability. Thank you, and see you in the next video.